Hey, physical science, it's Tuesday, May 5th. Can you turn with me to 559, please? Okay. I need to tell you what a superscript is. Now, if you take a look at the top, do you remember when we made these models of atoms? Well, the potassium atom is a picture up there where all the red dots are electrons. There's 2 on the first energy level, and you can see 8 on the second energy level. And it looks like there are 8 on the third energy level, and it looks like there's 1 dangling electron on the 4th energy level. Now look at iodine. Iodine has 5 energy levels, and you can see all the electrons distributed on those energy levels. But how many does it have on the outermost energy level? It has 7. And you can see right here on my periodic table that iodine, right there, is in group 7. And it has, if you run your finger over here, 5 energy levels. And on that 5th energy level, you can go ahead and go and see that there are 7 electrons on there. It needs 8 to be stable. So if it gains 1 more, it'll take on a charge of -1, because at that time, it will have 53 protons and 54 electrons, giving it an excess of 1, which is -1. And so, of course, 53 minus 54 is -1. And it will feel like it has like xenon stability on the outside. So when atoms are by themselves, they're electrically neutral, but they're not stable. That's why most of these elements combine with other elements to become stable. They either release electrons and others gain electrons, or they share electrons to become stable. And that would be a full outer energy level. If you look at the picture on page 559, you see 1 electron transferred from potassium to iodine. And then you see this symbol here, potassium, iodine. And what that is, it's a compound. We write it as Ki. We don't write the brackets. We write the brackets if we're just talking about the ion. This is a cation because we're positive on cats, and this is an anion, a negative ion. And that's what's formed because this one up here lost 1 electron. And this one gained 1 electron. And so that's why +1, -1 adds up to 0. Whenever there's a properly balanced formula, it will add up, the ions will add up to 0. This is a metal, that's a non-metal. This is called ionic bonding. Because the force that holds them together is electrical, because the ions are attracted to one another, opposites attract. So ionic bonding is electrical bonding. All right, and the atoms go to stability when they lose 1 electron in this case, and when they gain 1 electron in that case, because now both of these have an outer energy level that looks like the outer energy level of a noble gas. Okay, but the formula is written like this. Now, what if I wrote the formula for magnesium fluoride? I would tell you that magnesium fluoride formula is MgF2. I just know that. How do I know that? Well, let's just go ahead and take a look at, by the way, before we do this, the superscript, this plus and that negative, that minus, they're both set up. Superscript means written above. Okay? And so what is it that holds the potassium and iodide together? It's ionic bonding. Those are forces that hold atoms together. Let's look on the top of 560 where it defines ionic bond. It's the force of attraction between the opposite charges of ions in an ionic compound. It's an ionic compound because it's a metal and a non-metal. The forces that hold them together are electrical, and it's because the electrons have been transferred from one to the other. Look on the bottom of page 560. They have magnesium chloride. I'm going to go with magnesium fluoride, MgF2. What am I telling you? I'm telling you that it takes 2 fluorine atoms to make 1 magnesium atom happy. And the reason is because how many electrons does magnesium tend to lose? Well, magnesium is element number 12. And if you look up above element 12, you'll see that it has 2 dangling electrons on the 3rd energy level. 2 dangling electrons, when they're lost, it brings up a charge of +2, because magnesium starts out with 12 protons. You see that 12 right there? 12 protons and 12 electrons. But when it loses 2 electrons, because metals are losers, then it is +12 for the protons and -10 for the electrons. And so what is 12 minus 10? Isn't it +2? So how many fluorine atoms can it satisfy? Well, if you look at fluorine right here, you'll see that it is in group 7. And it only needs 1 electron to make it happy, to give it a stable octet. And so it gains 1 electron. But this one wants to give out 2 electrons. So you can make 2 fluorines happy. Fluorine is -1 when it gains an electron, and magnesium is +2, or 2 positive. But 2 positive means that it has 2 more protons than it has electrons. What 1 negative means is it has 1 more electron than it has protons. But you can satisfy another fluorine at -1 because they've got to add up these superscripts. These ionic charges have to add up to 0 if you have a properly balanced formula. And so what is +2 plus -1 plus another -1? That would be -2 plus 2 adds up to 0. And that gives you a stable compound, ionic compound. And you can see a picture on the bottom of page 560 that explains that. Now we're going to learn in the next section how to write formulas like this. And by the way, we need 2 fluorine atoms at -1 apiece. So all of that adds up to 0. Magnesium is +2 when it ionizes. Fluorine is -1 when it ionizes. And so, can I show you the trick right now? Later on, we're going to learn how to write a formula for magnesium fluoride. And first, we're going to write the symbol. We're going to write the symbol for fluorine. And we're going to put what I call oxidation number above them. The oxidation number for magnesium is +2. The oxidation number for fluorine is -1. You can call it ionic charge if you want. And then we do what's called criss-crossing. You're going to put a 2 down there, and you're going to put a 1 down there. And so your formula is going to be magnesium fluoride. Criss-crossing, just take the oxidation numbers. And what does that mean? That means you have 2 of these fluorine ions and 1 of these magnesium ions. and that's at 2 apiece, and this is at -1 apiece, and it adds up to 0. And so just if you do crissy-crossy, forget the sign, the SIGN, and just put a 1 down there and a 2 down there, and you're good to go. MgF2. Now, when you have a binary compound, 2 elements, you have an IDE ending. So instead of calling it magnesium fluorine, you call it magnesium fluoride. It's an IDE ending. Now look at page 561. On 561, we talk about molecules. Molecules are called a covalent bond. Metal, non-metal was ionic bonding. However, non-metal with non-metal is covalent bonding. What's a covalent bond on 561? It's the attraction that forms between atoms when they, here's the key word, share electrons. It's a neutral particle, and it results as a form of electron sharing, and it's called molecule. So if you've got a non-metal, we call it a molecule. If you have a metal non-metal, we call it a formula unit. But this is not ionic bonding. This is covalent bonding. Covalent means sharing. And so a non-metal, what did they give you? H2O. I've already talked about this. That's a non-metal, hydrogen. This is a non-metal, oxygen. And so we call it covalent bonding. It's sharing electrons. And this unit right here, which represents a compound called water, that unit is called a molecule. And you don't call this a molecule because it's metal, non-metal. You call that a formula unit. Now that I've written it, I'm going to erase it. I'm talking about molecules now. Molecular substances called covalent, held together covalently, bonded. Okay, so let's take a look at this. We've got oxygen, and on its outermost energy level, which is the second energy level, it has 6 electrons. 1, 2, 3, 4, 5, 6. And then the hydrogen comes along. It has 1 electron. He throws his electron in the middle. This one throws its electron in the middle, and they both play with that toy, those toys together. This hydrogen throws its electron in the middle, and that one throws its electron in the middle, and they play with those toys together. So the oxygen gets to play with 2, 4, 6 of its own electrons, and with 2 of those hydrogen electrons. This hydrogen is stable with 2, that hydrogen is stable with 2, the oxygen is stable with 8, and you have what are called 2 covalent bonds. This one and this one. It's called sharing bonds because they're sharing those electrons, and that's what holds them together. It's really just the overlapping of their electron clouds. Overlapping of their electron clouds holds them together. Now, multiple covalent bonds we'll do next time. Page 561. See you.